Hello, chemistry students. If you're watching this video, hopefully you've already watched the video on moles. In that video, we showed how we could easily calculate molar mass by using the periodic table for different molecules. And I kind of set that up where I would have you write out everything individually to help you understand if in later problems they were asking for percent composition or what percentage of, let's say, calcium is in calcium sulfate. Well, we're going to continue with that discussion in this particular video where we talk about using percent composition and those ratios and calculations. So one of the things is sodium is a concern in our diet every day. One of the things is it's a required nutrient, but how much is enough? So the FDA recommends about 2.4 grams of sodium in our dietary allowance. So what does that mean? Usually we consume sodium not directly as a explosive, extremely reactive metal. It's in the form where it's combined with chlorine to form sodium chloride, so table salt. But 2.4 grams of sodium chloride is not the same as 2.4 grams of sodium alone, because some of that mass in sodium chloride is contributed by the chloride itself. So how do we figure out how we do that? Well, that's what this video is going to show you. So we use mass percents. So mass percents are very simple. It's basically like any percentage. You have a part over a whole, and that's times 100, and that's how you get your mass percent. So what's the mass percent of sodium chloride or of sodium and sodium chloride? Well, how would you do that? You got to do part over whole. Okay, well, sodium chloride, right? Sodium is equal to roughly, we'll just say 23 grams per mole. And your chloride is roughly, 35.45 grams per mole. When we add those together, what do we get? We get 58.45 total for sodium chloride. So how do they come up with 39%, right? How do they come up with this 30? How do they come up with 39%? Well, if you want to figure out percent sodium, it's part over whole. 23 divided by the whole of 58.45 times 100 would equal 39. So that's how they get the percentage, part over whole. So this would give me 39%. Now, why is it useful to know the percentage of sodium and sodium chloride? Well, I can make that a ratio in my calculations, right? So there's 39 grams of sodium per 100 grams of sodium chloride. So we can go back to problems like we started out with and figure out, well, how many grams of sodium chloride do I need to consume to get the 2 grams of sodium, right? So I start with 2 grams of sodium and I figure out how many grams of sodium chloride. So we can do a long way, right? Using mole ratios. I could say, well, 2 grams of sodium, there's 23 grams per 1 mole, and then 1 mole of sodium, there's 1 mole of sodium chloride, because we just talked about mole ratios. And then 1 mole of sodium chloride is 58.45 grams. Or we could do how we calculated percent composition, which was part, that was the 23 grams I put over the 58.45, right? So if you look at the earlier slide right here, there's 23 grams of sodium per 58.45 grams of sodium chloride. That's how they got 39%. So if you know how to calculate molar mass, you know how to calculate percent composition, because I only want to know, right? I only want 2 grams of sodium. Well, there's 23 grams and 58.45, so I need to consume that much sodium chloride. Now, if they already tell you that sodium chloride is 39% sodium, you could just say, all right, well, 2 grams of sodium, right? There's 39 grams of sodium per 100 grams of sodium chloride. and you'd get the same answer. So there's literally 3 different ways to do this, right? You can do the long mole ratio way, which is fine. There's nothing wrong with that. If you understand that, do that. Or if they give you the percent, which sometimes they do, any percent, you just change to 100, right? So 39% of sodium means 39 grams of sodium per 100 grams of sodium chloride. If they don't give you a percent and they're just saying how many grams of sodium in sodium chloride, well, you'd have to say, all right, well, sodium is a +1, chloride's a -1. So my formula is NaCl, and then go about it the way I showed earlier. Either way, pretty straightforward. Part over whole. They might give you the part over whole, or you might have to calculate it from using molar mass, which we learned in the earlier video. So what about if I had glucose, right? So calculate the mass of carbon in 25 grams of glucose. So I could do the long way, which is okay, right? I would calculate, the molar mass of glucose. How did they get this? Well, they basically said, all right, 6 times 12, because the carbon, plus 12 times 1, because of the hydrogen, plus 6 times 16, and that's what, 72, plus 12, plus, what is that? 96, right? So 72 plus 12 plus 96 would give me this 180, okay? So you could say 25 grams of glucose, there's 180 grams per 1 mole of glucose, and in 1 mole of glucose, there's 6 moles of carbon, and 1 mole of carbon is 12.01 grams, so that's how many grams of carbon. So that's using mole ratios, totally fine, nothing wrong with that. What's a faster way? Part over whole, right? If I have 25 grams of glucose, I know there's 180 grams of glucose per 6 times the 12.01, which is what I did here to calculate molar mass, 72. Or 72.06 to be a little more accurate. And then that would give me the same number. Now there's another way to do this, right? I could have done the percent. I could say, well, what's the percent of carbon? Well, it's 72.06 over 180, right? 0.26 times 100 would give me the percent of carbon in glucose. Why do that? I've already calculated the molar mass. Why would I do this unless they asked me to give the percent composition of carbon? But if they gave me the percent composition of carbon, then I would plug that directly in as a ratio. Like in this problem, right? So here, you don't need to calculate the molar mass. They are telling me, right, in this dichloro-difluoromethane, you don't need to know the name of that, that's organic. But in this compound, 58.64% of it is chlorine by mass. So how many grams of this difluoro-dichloro or dichloro-difluoromethane contains 22 grams of chlorine? So you don't need to do what we did for glucose or sodium chloride. We don't need to calculate the molar mass. They're giving me the percent composition. That's when they do that, just say thank you. Because now all I got to do is say, well, 22 grams of chlorine. If it's 58.64% chlorine by mass, that's basically saying there's 58.64 grams of chlorine per 100 grams of this dichloro-difluoromethane. And that's what they did right here. And then I get my answer. So this kind of ties together our mole relationships, but also using our percent composition relationships to go from mass to mass within compounds. So you can use mole ratios, or we can use our percent composition and our mass ratios. I hope this video makes sense. Thanks for tuning in.